Today we'll be working on 1.6, 1.7, which will include solving literal equations and working with ratios, rates, and conversions. So starting off, today we're solving literal equations and working with rates, ratios, and conversions so that we can manipulate problems algebraically, that's the literal equation part, and contextualize problems, that's working with our rates, ratios, and conversions. And then we'll be able to do it when we can solve for x in a problem like r minus d times x divided by v equals p. So literal equations are equations that are filled with variables and don't have any numbers. So, or may have, a couple numbers or whatever. But for the most part, it's about following the steps to solve an equation without being able to combine or simplify numbers. So I've got a couple simple examples here in example 1. Example 1a, we have k times x equals w minus v. And we're being told to solve for x. And we may see these a lot of times with formulas, so like distance formula, distance equals rate times time, so d equals rt. Some of those things we'll see literal equations. So if I'm trying to get x by itself, and I know this is a little pixelated here, but I'm trying to get x by itself, it's multiplying with k, so to get rid of k, I have to divide it to both sides. Now here's the deal. I could either divide this entire quantity by k, or I can divide each individual term by k. For this, it cancels out, and I'm left with x equals w over k minus v over k. Because they're like terms, we could also, or because they have common denominators, we would also be able to write our answer as as x equals w minus v over k. So either one of those would work. What we could not do would be like x equals w over k minus v. That's no good because that k needs to divide to every term. So that wouldn't be an appropriate answer for this problem. Okay, in B, we have z equals m divided by x over y. So I like to start by kind of reading my equation, get a feel for what's happening, and we know this is x times y here. We have m divided by and z by itself. And I'm being told to solve for x, so that means I need to get this x by itself. So I'm going to rewrite that over here. Z equals m divided by x times y. Okay, so we're following our equation, the rules to solve equations, to manipulate this so that x can be by itself. So here's the deal. When I'm trying to get rid of or trying to get a number in the denominator isolated, I'm going to want to multiply that to both sides. And there's several ways to do this, so I'm just kind of thinking through the best way to explain this, because we could multiply x to both sides and have x times z equals, see, these would cancel each other out, m over y, and then I would need to divide z to both sides. So if I were to divide z here, now it's going to be hard to, what am I taking that whole thing and dividing by z? So I'm going to write divided by z here, and that's like z over 1, right, when we divide by z. So when we're working this out, these z's cancel out. And so we're following like mathematical principles and rules. We're applying them to variables. It's kind of an abstract way of thinking, but it's a good way to prove that you understand how solving equations works. So think about this. If I have m over y divided by z over 1, when we divide, we're actually multiplying the reciprocal. So I can think about it like that. And then I can multiply my numerators together, m times 1 to give me m, and y times z to give me yz. So that was all of this I worked out down here and got this. So x equals m over y times z. I'm going to back this up a second. I'm just going to take all my work here and move it over to the side because I wanted to point out, I kind of paused here when I was taking a look at this. There was another thing that I could do, which would be instead of just multiplying the x, I could multiply xy to both sides. And this may have been the easier way to do it. That's going to cancel these out. And then I'm left with xy times z here, so that's x times y times z equals m, and then I can divide y and z to both sides to get x by itself. That might actually be the simpler way. X equals m divided by yz. So as you can see, there are like some different ways to approach this. You can do it one piece at a time. This one I was able to take care of multiple things. It's just about kind of building that confidence and getting comfortable with it. So here we have c divided by a equals d plus r. So this is a multi-step literal equation. And we need to get a by itself. So here's the deal. I'm going to rewrite this because it's so pixelated. C over a equals, I thought I'd be clever and like take snapshots of the problems and then just embed them into the notes, but they get pixelated out, I've learned. So I need to get a by itself. It's in the denominator. So here's what I need to do. I need to multiply a to both sides. So these a's cancel out, and I have c by itself equals, and I am going to see there are several ways we could approach this. I can distribute in my a. So think about a times d would be AD, and a times r would be AR. But that's not really getting a by itself. That's creating more. Now I have more a's to deal with instead of less. So instead of doing that, let's leave it as multiplication. So I'm just going to rewrite this as a times d plus r. Because of the commutative property of multiplication, it doesn't, or the, yeah, commutative, it doesn't matter where my a is. They're multiplying. So like 4 times 5 is the same as 5 times 4. So even though I moved these around, it means the same thing. So if I'm trying to get a by itself, and it's multiplying with this whole quantity, d plus r, then we're going to do the inverse, and we are going to divide the quantity d plus r to both sides. And those will cancel each other out so that a is by itself equals c over d plus r. So these are kind of abstract, but again, we use what we are allowed to do in equations to solve. So example B, so 2b, we're doing u equals x times y divided by k. And I need to get x by itself. So in order to get x by itself, I'm going to need to move both the k and the y. So I'm going to multiply k to both sides. That's going to make those cancel out so that I'm left with ku equals xy. Now if I need to get x by itself, from here I can divide y to both sides. That'll make those cancel out so that ku over y, sorry, that u looks like a y, equals x. I'm also allowed to write it the other way around. X equals ku over y. So either way would work, okay? Let's look at some more practice problems. These are getting increasingly more complex, but I want you to see how we are able to handle these. So if I need to get x by itself in this example, so I have z equals p plus n plus x divided by m. And I am trying to get x by itself. I'm going to subtract p from both sides. I can also subtract n to both sides. So that's going to make those two things cancel out. And now on my left side, I have z minus n minus p equals x over m. And now, to get rid of my m, it's dividing the x, right? So x divided by m. And the inverse operation, or the opposite of dividing, is to multiply. So I can multiply m to this side. And remember, when we multiply, we're multiplying to, we can either do it to individual terms like this, and each one's going to get multiplied by m, or I could have done, just back it all the way up, I could say this whole group times m, because remember, our distributive property means that everything's going to get an m as well. So it kind of means the same thing. So these will make these cancel out. I'm going to rewrite my answer. I'm going to write x first because that's how I'm used to seeing it. I can flip-flop my sides. So x equals, and then I'm going to work this out. M times z is mz. M times negative n is negative mn. And m times p, negative p is negative mp. So that's our solution here, or that's our answer. Again, we're just following rules to move stuff around. So in this one, I need to get a by itself, which means I'm going to subtract r and I'm going to subtract d to both sides. And that will give me g minus r minus d equals c times a. Now in this one, I have to get a by itself, which means it's multiplying with the c right now. So I can divide the c to both sides. And again, I can either say this whole group divided by c, or I can say each individual term divided by c. Because it would be a common denominator, we can write it either way. So that'll make that cancel out. And we're left with a equals g over c minus r over c minus d over c. The other way we could write that is a equals g minus r minus d all over c. All right, last couple. This one we're solving for x. So right now x is being multiplied by c, and I need to get rid of that c by dividing it. So think about, I'm going to divide c here, which means I can, I'm going to take this and I'm going to have to just say divided by c. And this one, I can say divided by c. So when I have a fraction, I don't like making double fractions. So I'm going to do my work here. R over d divided by c. So think about when we divide, we're actually multiplying the reciprocal. So that's c over 1. So r over d, times the reciprocal, which is 1 over c. And then we can multiply our numerators together, r times 1 to get r, and our denominators together to get over d times c. Okay, so that was just for this piece here. So I'm going to take my x and rewrite it because these canceled. So x equals, I did all of this work here and got this. So x equals r over dc plus y over c. And that would be our solution. Okay, and then finally we're going to solve for a over here. So I'm getting rid of whatever's adding or subtracting first, which means I can subtract p to both sides. Oh, sorry, that wasn't even both sides. There's both sides. Okay, so I can subtract p to both sides. I can also subtract n. So that makes those go away. So now I have on my left side z minus n minus p equals negative m over a. And I need to get a by itself. So hang with me here. In order to get rid of a that's in the denominator, I need to multiply it to both sides. Remember earlier, instead of multiplying individually, I can write it out front like that. So that's going to make those cancel out, and I still have negative m on this side. And I have a times z minus n minus p over here. And if a is multiplying with all of that, I don't want to distribute that in because then I'm going to have to take care of each one of those individually. But if a is multiplying with this whole quantity here, then that means I can divide that whole quantity. I'll do that in blue. I can divide z minus n minus p. And that's going to cancel that out to give me a all by itself. But what I do to one side, I have to do to the other. So I'm going to do that in blue over here as well. I'm doing divided by z minus n minus p. And there's not really anything to work out here. I could I could apply the negative and flip things around, but I'm just going to leave it as negative m over z minus n minus p. Okay, so those are literal equations. We're just taking variables and manipulating them around using the rules that we are allowed to apply to equations.